Hello everyone, this is Mr. Sutherland here on behalf of the AP Calc team. And my job today is to introduce everyone to the free response topic review packet. We are going to start working through one of these topics today. And as we continue through our AP review, we will do most of these other topics that you see listed here below. So those of you that picked up this packet before break, this was the green packet. Very similar to our multiple choice packet that was pink, except this one focuses on just free response type questions. And it is built in a similar manner in that we have organized questions by the most frequently tested topics. And if you did not get a chance to pick this up before we left, then your teacher will have a link to a PDF of the document that you can either print or just do the problems in your own notebook. So the topic that I'm going to focus on today is the topic of differential equations, which was the most recent topic that we covered as a class. So if we take a look at topic 6, differential equations, each topic in the packet starts with a page which will have a list of bullet points of what students should be able to do when asked these types of questions. And so when we look at differential equations, take a moment, read through these. If you need to, pause the video. And then what I would like to do is just discuss a couple of them in particular that I think are important. So obviously the ones here that are going to be tested the most often are the first two, being able to find a general solution to a differential equation and finding a particular solution when you have that point value that you can use to find your constant of integration. The method that is used in our course to solve differential equations is separation of variables. And this was the process that we were using before we left for break. Typically in these problems, you will have to sketch a slope field, and sometimes you'll have to draw a solution to a slope field, like given a point, draw the curve that follows that slope field. And then there are other little problems that are built into these, but those are the main things that are going to be asked of you. So with each of these topics, you'll start off with a list like you see here, and then we have provided 3 practice free response questions. So for today, what I'm going to do is go through one of these questions with you, and then you can try the other 2 as part of your work for the course. Now, what I would suggest is I'll read through the prompt, and then you should pause the video, try the problem, and then unpause and go through my solution and see how you did. Each question will tell you at the top whether it is a calculator or no calculator question. So you have that. And each question would be scored as a typical free response with 9 points. So the first question we have, it says, consider the following differential equation. And it says on the axis provided, sketch a slope field for the given differential equation at the 6 points that are indicated. So if you remember from before spring break, when we talk about sketching a slope field, what we're doing is just finding the slope at a certain point on the coordinate grid and sketching just a tiny segment that represents the slope of the curve at that point. So for instance, if I were to look at the point 2, 1, according to our differential equation, remember dy dx is the rate of change which represents the slope, we get that if I plug in here, we get that slope, if I plug in 1 for y and 2 for x, we get that this has a slope of 1 over 1, so 1. So I just draw a little segment that looks like it has a slope of 1. Now, if I do that for all the points here, and I'm not going to write out each of the work for each of these, if I were to go to 0 for this first point, well, it's 0 for y, so that is a horizontal, that's a slope of 0. That means 0, 0 is going to have a slope of 0. The point 1, 1 is not on here, so the point 0, 1, if we do that, if I were to plug in 0 for x and 1 for y, I actually get a slope of -1. At 0, 2, I get a slope of -2. And at 2, 2, I get a slope of +2. Now notice they didn't ask about 1, 0, 1, 1, and 1, 2. And the reason that happened is there the slope would be undefined. And so a lot of times the rubric will say you can just leave that blank. You could draw a vertical tangent line, but what the AP question writers tend to do is just avoid those values where it is undefined. So there is no ambiguity there. So they just have those 6 points. Part B. Let y equal f of x be the particular solution to the given differential equation with the initial condition f of 2 is 3. Write an equation for the line tangent to the graph y equals f of x at x equals 2. Use your equation to approximate f of 2.1. So they're asking us to find the equation of a tangent line and use that for an approximation. So let's think about, since the beginning of the year, if we've asked you to write the equation of the tangent line, we need to know the slope of the tangent line. Well, the slope of the tangent line is given by the value of the derivative at the point that we're looking at. So at the point 2, 3, we would have 3 squared over 2 minus 1. So we get that the slope of the tangent line to be 9. Next, we need the point that the tangent line is going to use, and that's given to us by f of 2 is 3. So we have the point is 2, 3. And then we can write our tangent line equation. Now, if you remember, we've always said just write it in slope form. So I have this, and because I know I'm going to be finding the value of the function, I'm not going to distribute everything. I'm just going to move that 3 over to the right-hand side. And so now they want us to use the tangent line to approximate the value of the function at 2.1. So that just means we take our tangent line, and where we see 2.1, we plug in, or we see x, we plug in 2.1 for that value. So here we would have 0.9 plus 3. So the value approximately would be 3.9. Part C. Find the particular solution y equals f of x to the given differential equation with the initial condition f of 2 is 3. Now the key here is that when they ask for a solution to a differential equation, they are asking for an equation where that it makes that differential equation true, that passes through the point 2, 3. So most of the time when you're told find the particular solution to a differential equation, and there's x's and y's in the differential equation, that is when you're going to use separation of variables. So we know dy dx is equal to y squared over x minus 1. So if I move things around, I get 1 over y squared dy equals 1 over x minus 1 dx. Now, we're next going to find the antiderivative of both sides. The biggest problem or mistake people make with this is with the left-hand side, 1 over y squared, people want to jump to log, natural log, for the antiderivative. But remember, that only works if it were y to the first. Instead, we need to think of this as being y to the negative second, 1 over x minus 1 dx on that side. And so when we find the antiderivative, we're just using reverse power rule on the left-hand side. So I would have negative 1 y to the negative first. And on the right-hand side, I have natural log absolute value of x minus 1 plus c. Don't forget your constant of integration. So this would be negative 1 over y equals natural log absolute value of x minus 1 plus c. Now I can plug in the given condition to find the value of c. And if I do that, I get negative 1/3 equals natural log of 1. Notice the absolute value can go away because the absolute value of 1 is 1. And then natural log of 1 is 0. So I have negative 1/3 is my c value. So where are we at this point? Now we have our equation, negative 1 over y equals natural log absolute value of x minus 1 minus 1/3. And we need to solve this to get y by itself. So when I move things around, we end up with y equals negative 1 over natural log absolute value of x minus 1 minus 1/3. This would be the solution to the differential equation. And there are different variations of this answer that would all be correct. For instance, sometimes you want to keep a fraction within a fraction, so I can multiply everything by 3 and have negative 3 over 3 natural log absolute value of x minus 1 minus 1. I could switch where the negatives and positives are, but you don't have to do that. The solution that I starred would be acceptable. So now what you should do is work on the next two questions. Your teacher will post the key so you can grade yourself and see how well do you remember and understand differential equations.